Steam, hissing power that helped position America at the apex of a global industrial hierarchy. Steam, robust, dynamic energy that drove an emerging giant through a crossroads of tremendous social, economic, and technological change, propelling it from an essentially agricultural nation to a nation of factories and seemingly unlimited manufacturing potential. Steam, to power construction equipment, cotton gins, steel mills, to pump water, to provide heat and light, but most importantly, to power the unifying force of this great upheaval, the iron horse. The railroads made America's brilliant rise to an industrial power possible. They united a vast and diverse nation, bridging geographical distance and providing the foundation for America's industrial complex. And they ran on steam, steam that escaped from poorly sealed pistons, reducing power and efficiency. But Olin James Garlock, like so many Americans before him, had a better idea. In 1886, he was granted a patent for his packing rings of cotton duck and rubber, which dramatically reduced sealing failure while increasing efficiency. He went into business soon after, founding a company on a heritage of innovation and pride, a heritage that would sustain it through its first 100 years and beyond. Garlock always has been and always will be a leader. Through the years, we've been the trailblazer that others followed. In the 1940s, we introduced lattice braid construction. In the 60s and 70s, carbon and graphite packings. And in the Garlock tradition, we were 5 years ahead of the industry in committing to totally asbestos-free materials in 1981. Garlock's leading posture is supported by a number of innovations. Our yarn coating and application technology treat each individual strand of yarn, assuring long life, precise consistency, and maximum effectiveness. Unlike most of the competition, we manufacture our own yarns and customize and highly modify our braiding machines to meet our exacting specifications. Our products endure the most thorough and rigorous testing programs in the industry, implemented through fully functional pump and valve testing equipment, including a unique fire safety testing facility. And rigid quality control guarantees consistency and reliable performance. No one manufactures the same diversity of packing materials to meet as many applications as Garlock. From simple water pumps to power plants, Garlock supplies virtually every industry. And although we've diversified and expanded greatly from O.J. Garlock's day, compression packing still represents a significant portion of our business. To maintain our commitment to customer satisfaction and training, Garlock presents this tape detailing the proper installation of compression packing in pumps and valves. Various packings may be constructed of different materials, and although their precise functioning may vary, the mechanics behind their operation are the same. Rings of the material are placed around the shaft of the device being packed, filling the stuffing box. The material is then compressed by tightening a gland follower. This causes the packing material to expand radially against the stuffing box bore and shaft, creating the desired seal. In applications where the shaft is in motion, such as pumps, the packing must contain lubricants to act as blocking agents and to reduce friction. Such materials usually permit a small degree of controlled leakage. Valves generally are sealed with materials designed to completely eliminate leakage. Whether sealing a pump or other rotating equipment, proper packing selection, installation, and system startup procedures are extremely important. Most packing failures are a direct result of improper procedures in these areas. The first step in repacking a pump is assembling the required tools and materials, which include a wrench, a flashlight and inspection mirror, a tamping tool, packing pullers, inside and outside calipers, a cleaning cloth, break-in lubricant, safety glasses, a sharp utility knife or packing cutter, and new packing material. Begin the installation by carefully removing all of the old packing from the stuffing box. Examining this old packing can often assist in resolving functional performance problems directly related to material selection. Charring and burning of the ring's inside diameter could be an indication that the packing material lacked sufficient lubrication or was not capable of withstanding the temperatures present in the system. General deterioration may indicate chemical attack and an incompatibility between the packing material and the system fluid. In such cases, a more chemically resistant packing material must be used. For assistance in choosing the proper material, use the rule of stamps, which provides a simple listing of the following important considerations: the size of the packing required, the temperature of the media, the application, what type of equipment is being packed, the media being pumped or sealed, the system pressure the stuffing box is subjected to, and the shaft speed in feet per minute. For further detailed assistance, contact your local Garlock distributor or Garlock factory representative. After selecting the proper packing material, the pump may be repacked. Using a flashlight and mirror, inspect the stuffing box, the pump shaft, and the shaft sleeve for wear. If the shaft or shaft sleeve are excessively worn, replace them. If shaft runout exceeds the pump specifications, correct it. If you are packing an unfamiliar pump, it will be necessary to make measurements to determine the proper material size and the required number of rings. First, using an outside caliper, measure the diameter of the shaft. This gives the inside diameter of the packing ring. Using an inside caliper, measure the diameter of the stuffing box. This gives the outside diameter of the packing ring. To find the correct material cross-section or size, subtract the inside diameter measurement from the outside diameter measurement and divide by 2. Now, using a flexible scale, measure the stuffing box depth. Divide this figure by the cross-section measurement obtained earlier. This will provide the required number of packing rings. Fractions should be rounded to the lowest whole number. When cutting rings, use a packing cutter, such as a pack boy, or a mandrel of the same diameter as the pump shaft. Rings may be cut with a butt or bevel joint. If the rings are properly cut, there will be no performance differences between butt or bevel joints. Check the first ring for proper fit before cutting additional lengths. Make sure the ends fit snugly with no gaps. It's possible to eliminate cutting altogether by using pre-cut material. Install one ring at a time. Make sure it's clean and coat the inside diameter with a thin film of break-in lubricant. Position the rings so that joints are staggered by 90 degrees. Each ring should be seated with a tamping tool to ensure that they are positioned correctly in the stuffing box. If a lantern ring is used, it should be positioned slightly outboard of the flush port. This will permit correct alignment when the gland follower is tightened and when additional compression is applied to the packing during normal use. After installing the proper number of rings, the gland follower should be drawn finger tight. The last packing ring should not extend past the stuffing box face, and the gland follower should be positioned just inside the stuffing box. If a lantern ring was used, start the flush. Start the pump and allow a moderate level of leakage for 15 minutes. Evenly and gradually tighten the gland follower until leakage is reduced to the desired amount. Never stop leakage entirely. Some leakage is required to lubricate the packing rings. Remember that proper material selection and installation are the vital ingredients in any successful pump packing application. Repacking valves is similar to repacking pumps. The same tools are required, and proper material selection is equally important. The procedure is essentially the same, but there are some distinct differences. Begin by securing the gland follower to prevent interference during the initial steps. Remove the old packing and check the stem and stuffing box for wear. Measure the stem diameter, stuffing box bore, and box depth, and use the same formulas employed in pump packing to determine the correct material size and the required number of rings. As with pump packing, correct material selection is vitally important. Some usages dictate combining rings of different materials. Garlock offers a variety of superior products with functional parameters to meet virtually any application. Rings may be cut with butt or bevel joints, but cutting to the correct size is more important than joint selection. Individually seat each ring with a tamping tool, remembering to stagger the joints by 90 degrees. The set compression applied will depend on the packing material used. It's important to follow the packing specifications in this area. If you have any questions, contact your Garlock representative. After the packing has been installed and compressed, actuate the stem through 5 complete cycles to ensure an even distribution of load throughout the set. After this cycling, it's good practice to recheck the gland stud nut loading. Selecting the proper material and following the correct installation and compression procedures will virtually assure a successful repacking job. If you're experiencing trouble in a pump or valve application, examining the old packing, which may also have assisted in material selection, might indicate improper procedures or mechanical problems which led to unsatisfactory performance. An axial bulge in any of the rings might indicate that the adjacent rings were cut either too short or too long. Wear on the outside of the rings is often an indication that the rings are rotating with the shaft. This may be caused by using a packing size that's too small, cutting the rings too short, or by improper seating of the rings. Extrusion of the packing material could be an indication that the gland follower or stuffing box clearances are a problem, or that the packing material lacks the integrity to withstand the system service conditions. Packing rings that have excessive wear on one side may be caused by shaft runout or an off-center pump shaft. Compression packings perform vital functions every day in a vast array of industries. Their effectiveness and efficiency help keep American manufacturing plants productive and competitive. But as technologies become more sophisticated, demanding increasingly stringent requirements, the demands on packing materials will increase as well. And spearheading the development of innovative and groundbreaking compression packing products will be the leader, Garlock. Garlock, a company founded over 100 years ago on a better idea and on values and principles that never age. Innovation, quality, customer satisfaction, performance. That's Garlock.